Hello there, ICS3U folks. This video is going to take up the sorting walkthrough that we did the other day. And not the entire thing, and I never asked you to do the entire thing, but the idea is, of a walkthrough is to pretend you're the computer, execute commands, and change kind of our memory setup as we go. And it is a tedious but important skill in computer science, and so I'm going to get us started. You have your note there, and I'm going to adjust this. And by the way, the answers, the full solution should be around somewhere, and you can have a look at that after you're done with the video here. I'm going to try and go reasonably quickly. Don't be afraid to stop and ask, because I'll be right there in the room with you as you're watching this, most likely. Okay, so the first bit here, and you can see my cursor over there. I'm on this line right here, Notice that this actually would make a memory location as well, called max value. And since it's final, though, it doesn't change. We can't change a final value, so I'm never even bothered putting that into memory. And what it's used for, remember, is that's kind of used to wipe out the original unsorted values. So the next line is this line, and it assigns those 6 values into the unsorted array. So it starts over here. Spot 0 is 4, and then 12, and then 6, and then 1, and then 5, and then 2. And I'm going to space some of these out just so it matches up with the numbers above these are the index values, right? So unsorted 0 is 4, unsorted 1 is 12, and so on, right? And hopefully you got that. And then the next line, this line here, creates a new array, and that's also 6 units long. And notice it says in the comments over here, we could have initialized it to be unsorted dot length, which would be more general, and that would be actually better. Notice that, and I'm skipping this because it's a little bit strange. When I make this array of integers, it actually creates 0 values in there. So there's actually 0 values in there. And so anytime if we wanted to print out sorted 0, sorted 1, sorted 2, they would actually show zeros, not nulls. They would show zeros. If we left off that part, this part here, and just declared it, just did this part, then it would be nulls. But by creating the array, it gives it some default values, which are zeros. All right. Next line is to initialize the location, and LOC is going to be used as the location of the smallest value. And the smallest is equal to the max value. So it's initialized to be some huge value. And I'm just going to use 999 instead of putting this whole big long integer in there. When you see 999, you'll know that we mean max value. The idea there is as soon as we find any value, it's going to be smaller than that. And we're not going to find a smallest value that's actually bigger than this huge number. So this is kind of gives us a starting spot. And then we start into our loop. And I'm going to actually have a new line in my table for each value of I. So I equals 0 is how it's initialized, right? I equals 0 gets initialized, tests this condition, and then goes, and if it's true, and it is, 0 is less than unsorted dot length. Unsorted dot length, remember, is an array method that returns the length of the array, which is 6. So as long as I is less than 6, then this is going to keep going. So, and it says purpose of this outside loop is to put the ith smallest integer of unsorted into its correct place, and we'll talk about what that means in a second. But then we're into the loop because this was still true, this condition was true, so we're into our loop, and smallest is equal to max value, so that makes that 999, even though it was already 999. It still executes that thing and initializes the location to be 0. And notice that I'm kind of, even though these memory spots are kind of on top of each other, I'm making the table go down so I can kind of see how many commands have been executed. And then I go into the next for loop. The inside for loop is where j is initialized to be 0. So j is initialized to be 0, and as long as it's less than the unsorted length, it's going to continue. So then j is equal to 0, and then I'm into this inside for loop, this end of inside in this inside for loop. So it's going to check if unsorted j is less than smallest. Well, what's unsorted j? That would be unsorted 0. Well, unsorted 0 here has a value of 4. Is 4 less than the smallest value? Well, the smallest value was 999, so this is true. This is true, which means this code here is going to be executed. If this was false, this wouldn't be executed. So smallest is going to be equal to unsorted j. So the new smallest is equal to unsorted j. Unsorted j, j was 0, is equal to 4. So that means the smallest so far is equal to 4, and then this line keeps track of the location. Location equals j. So where did I find that smallest value? Well, j was 0. Dandy, it ends the end of the if, end of the for goes back up here, increments j, so j goes from there to 1, and then it goes into this again. So now unsorted j is unsorted 1. Well, unsorted 1 is got the value of 12. So is 12 less than smallest? Well, notice that it was less than the original smallest, but the value of smallest now is 4. So is 12 less than 4? No, it's not. It's not going to execute these commands because this is not true. So it's going to end the if, end the for, back up here, increment j. So then j becomes 2. J becomes 2, and now we're talking about unsorted 2. Is unsorted 2 less than smallest? Well, no, because unsorted 2 is equal to 6. Is 6 less than 4? No, that's not true, so it doesn't execute that. Ends the if, goes up to the 4, increments j, tests the condition. J is still less than unsorted length, right? It's unsorted dot length is 6, so it's still true. And then you see in what this inside loop, it's looking for the smallest integer left, right? This inside loop is looking for the smallest integer left. So I have the value of j is equal to 3. So is unsorted 3 less than smallest? Unsorted 3 is equal to 1. Unsorted 3, this is 1 is less than smallest. Is this true? This is true this time, and so smallest, way down here, smallest is going to be equal to unsorted j. Unsorted 3 is equal to 1. So that means smallest is going to be assigned the value 1. The location is j. So it says that I found this new smallest value in position 3. Ends the if, ends the for, bumps up the j. Test the condition, that's still true. That's still true there. And then now it checks the next one. Is unsorted 4 less than 1? Well, we can see that the last two values aren't going to be less than 1. So it's going to test them, but it's not going to execute these codes because it's not going to be true. So it goes through once. J doesn't work for 4. Bumps up to 6. And then finally, when it bumps up to 6 and checks the condition, it's not true anymore. Okay, it's not true anymore, so that means this inside for loop conks out. It conks out, and then what happens? Well, finally, we execute this line down here. Sorted I equals smallest. So sorted I equals smallest. Sorted I, well, what's I? I is 0, so sorted 0 is equal to smallest. Smallest is equal to 1, so the position in this sorted value, sorted 0 becomes 1. The rest are still blank, or zeros really, but I'm just going to leave them blank to say that we haven't done anything in that array. So what happened there? That found the 1 and then put it into the right spot. 1 was the lowest number. It goes into the 0th position. All right, okay. So then what does this command do? Unsorted loc is equal to max value. Loc is 3. So unsorted 3, I'm going to copy this and bring it way down here so we can see where it changes. Unsorted 3, where the 1 was, right? That's unsorted 3, is equal to max value. So that means we take the 1 and wipe it out. Now, why do we do that? Remember, that was so the next time we go through the loop, it's not going to find the value 1 as the smallest anymore. All right, I'm going to keep going. You've probably got the idea, but I'm going to keep going through the next iteration of the loop, and then probably that's about it. Insert a row after there, and so then I can start again. So what happened there? I just executed that. Get to here. This is the end of the for loop. Bumps up the value of I. So I goes from 0 to 1. It tests this condition. It tests that condition. And that's true because unsorted dot length is 6. 1 is less than 6. So it doesn't conk out of this outside for loop. It goes into this inside for loop. This line gets executed and smallest becomes max value. Remember, the reason why we did that was so it reset. Loc equals 0, reset the current location of the smallest value. It says, okay, we're going to start looking again. That's what that's saying. And then we go into the inside loop. J gets started and initialized as 0. And then we're starting into this whole process again. If unsorted J is less than smallest, unsorted J, unsorted 0 is 4. So this is true. Unsorted J is less than smallest, because smallest was reset to be 9999. So then this inside thing gets executed. Smallest equals sorted J. Unsorted J was 4, right? Unsorted 0 was equal to 4, and then it keeps track of the position of that. Ends the if, bumps up the J from 0 to 1, and then has another go. Is unsorted 1. This is the value of unsorted. Unsorted 1, is it less than smallest? No, smallest is 4. And so that doesn't execute, bumps up the J, bumps up the J, bumps up the J until it finds one that's smaller. And notice that it doesn't find a smaller value until J equals 5. And at J equals 5, finally this inside condition will be true. Unsorted 5, which has the value of 2, unsorted 5, remember 0, 1, 2, 3, 4, 5 is now finally less than our smallest, current smallest, which was equal to 4. It gets reassigned to the smallest. So down here, when J is 5, then we find the next smallest value, which is 2. We keep track of the location, which was in position 5, and then J gets bumped up to 6, conks out of this inside for loop, and then finally we're executing this command. So sorted I, so sorted 1, sorted 1, sorted 1, that's the second position in the array. I'm going to copy this now in here. So this second position, sorted 0 is 1, sorted 1 is equal to our smallest value that we found, which is this column, which is 2. It is smallest. That sort of put that spot, that one into the same spot. And then that's that command. The next command is unsorted loc equals max value. So unsorted loc right now is equal to this array. So I'm going to put this way down here again so I can see about where it's changed. What spot in our program was it changed? So it says the loc had the value of 5, so unsorted 5 becomes the max value. 0, 1, 2, 3, 4, unsorted 5 becomes 999. And so that wipes out the 2 in the unsorted array, and then we continue. Okay? The rest, I'm gonna stop the video there. The solutions are posted. Notice I've got it right here, so I'll show you. There's the solutions. It's quite long, right? So there's where I equals 0, I equals 1, I equals 2, and notice J goes from 0 to 6 each of the times, and then eventually we end up with unsorted having a bunch of 9s in it, and then our final array being sorted, and then it finally prints out using another copy of I. I also have in this file the swap one, which is significantly shorter. Check your answers, walk through this, be patient and careful, and hopefully you followed some of this. Don't be afraid to ask if there's a line of code you're not sure of, or a value in my walkthrough that maybe I made a mistake in or you're not understanding. Okay, hopefully you made it through that long video.